Now we will look at the sixth learning outcome of this topic further integration, which is whatever differential equation techniques we have learned so far, we need to apply it to applications in real life. Yeah. So I will discuss a few examples here. So for the first example, the very popular one is the Newton law of cooling. Yeah. It states clearly that rate at which an object cools is proportional to the difference between its temperature and that of its surrounding. Yeah. So example, if T is the temperature difference at time T, then we take TO as initial conditions, and T, when time is at the beginning, initial condition, you need to express T in terms of temperature in terms of time. Yeah. So for example, dt is proportional to T. So this is Newton's law of cooling. dt over T is proportional to capital T. That means the temperature. So we add a K, because when we are changing the proportionality, when we change it to equality, you need to add a constant. So we use a K. Okay. And then we use the separable variable technique where we split the dt with T. So dt over T equals to K dt. Okay. So next step would be integrating both sides. So in order to integrate both sides, you will actually get ln t, because it's integrating 1 over t. Don't forget your modulus. And you will get integrating k gives you kt plus c. So we are going to make an assumption that your c is ln c. You can use any other letter. Okay. So so it will become ln t minus ln c. Bring the c over to the left, it becomes ln t minus ln c. So it's ln t over c equals to kt. So in order to get rid of ln, you actually introduce e to the power of kt on the right. Okay, so t over c equals to e to the power of kt, and we bring the c over it. T equals to c to the power of e c to the power of e kt. Okay, and then using the initial condition, we substitute C as TO. Okay, and substituting it, you will actually arrive to your final particular solution, which is TO e to the power of KT. Now we will look at the second example where you are given a differential equation. Find the general solution and illustrate it graphically. So for this part, the first step would be when you have x and y and dy dx. When you study the function, definitely in order to get a general equation, you need to integrate. So you need to split the variable first, or separate the variables. Y with y, just cross multiply, and x with dx. When you integrate both sides, you get this form. Right? Your next task is making y the subject of equation. So in order to make y the subject of equation, need to rearrange the equation. You multiply the whole equation with 2. Okay. So when you look at this equation, it is x squared plus y squared equals to 2c. Obviously, this is actually a circle equation where the center is 0, 0, which is the origin, and the radius 2c equals to r squared. Therefore, the radius is actually set of 2c. So when you want to draw it, you can actually illustrate a few circles based on the same center, because the value of the radius depends on the coefficient of c. In the third example, discusses on a population model. So one theory states the rate of change of population is dp dt is proportional to the population, which is p. So therefore, you need to come up with the equation first. So dp dt is proportional to p based on this sentence, and you need to express p in terms of t. So therefore, you need to apply separable variable integration technique. Yeah. So in order to write it as equation, you need to introduce an unknown, a constant, which normally we use k. Okay, and then you need to apply the separable variable. So dp will be over p and k will be paired with dt. Okay, and then your next step would be different integrating both parts. So it will be ln p equals to kt plus ln c. We are taking the c as ln c here because it will be kt plus c, right? So we took the c as ln c in order to ease the calculation so that we can collect the ln together on the left hand side. Okay, so it will become ln p over here. It will become ln p minus ln c. Okay, so it will reduce to ln p over c. So it reduces to ln p over c, and we introduce e on the right hand side. Okay, so it becomes c multiplied by e to the power of k t. Right? So once you arrive to this, you have already expressed p in terms of t with the given unknown.